right, so in this video, we are going to be discussing graphing two variable equations, but more so treating them as functions, right? So linear functions is going to be more the word we're going to use in this lesson and inadvertently in this video. So we're going to hereby start referring to, instead of y equals mx plus b, we're going to say f of x equals mx plus b. And all we mean by that is we're saying that whatever y is, right, whatever y is, will depend on x because y is the dependent variable. Therefore, we can say that y is a function of x. Okay, so whatever y is, right, it's a function of x. Okay, so f of x has a y-intercept of negative 23 and a slope of 6 over 5. So f of x equals m x plus b. And there you go. Okay, passes through the point. So this is our point x1, y1, yes? With this slope. Okay, obviously we're going to use il pointo slopo. Right, so first, well, just put the numbers where they go. Y minus y1 is equal to m, right? This is m, times x minus x1. Okay, so this right here is a double negative, so we can just say y plus 13. And then I'm going to distribute my slope into here, so negative 3/8 x plus, well, this is 3 over 8, right? So this is negative 3 over 8 times negative, this is a negative 8, negative 8 over 1. These 8s are going to cancel. And positive times negative times a negative is a positive. So that's going to leave us simply with plus 3. Okay, negative 3 over 8 times negative 8 over 1 is just a 3. So almost there. Now I just need to subtract 13 from both sides because of that guy there. Obviously, because I want to get y or f of x by itself, right? So now I'm going to say f of x, because that's what y is. We're being grown-ups now, and we're calling it f of x, is equal to negative 3/8 x. So mx, and then I'm doing minus 13. So minus 10. Final answer. Okay, last one. F of x passes through these 2 points. So x1, y1, x2, y2. That means we need to utilize 2 formulas. We're going to utilize this, again, point slope, but we're also going to utilize our formula for slope, which is delta f over delta x, or the rise over the run, or the change in y over the change in x, or in this case, change of f, right, over the change of x. So either way you look at it, right? Okay, so 4 minus 9 is going to be over negative 2 minus 8. Okay, so that's going to give me negative 5 over, negative 10. That's going to be positive 1/2 is going to be my slope. Okay, so now I'm just going to plug into, point slope here. So y minus y1 is equal to m times x minus x1. And that's going to give me a double negative. So I'm just going to go ahead and put that it's plus 2, right? Because it would be minus negative 2. Okay? So I'm going to distribute the 1/2 x plus 1, right? Because 1/2 times 2 would just be 1 for the same reason that happened over here. Okay, so then we're going to also add 4 to both sides. Okay, so now I've got f of x equals 1/2 x plus 5. And there you have it. Final answer. Okay, So, really quick, I'll go over this example here. So, velocity. Velocity is the change of position with respect to the change in time, right? And acceleration would be the change in velocity with respect to the change in time. So I wrote quite a word salad here explaining both concepts. If you need to pause the video and go ahead and read up. Okay, so here we see a situation about paranoid Pete. And again, if you need to pause the video, go ahead and read up. And here we're going to actually work through this. Okay, so we see that they're working for Elon Musk at SpaceX now, and there is a jetpack, right, that is capable of a sustained acceleration rate of 64 feet per second squared, or 64 feet per second per second. Okay, so I'll let you read through that, what that means, right? So the jetpack wearer, uh, we're trying to see, right, how long it's going to take for them to reach Mach 1, the speed of sound. And we're given the speed of sound here. Okay, so number one, if v is the velocity, right, of Jeffrey in the jetpack in feet per seconds, right, and t is the time in seconds, which variable is dependent and which one is independent? Well, like I always tell y'all, time is always independent. Time doesn't depend on anything unless you start getting into relativity, and then time can inadvertently depend on like mass or energy, and that's a whole nother. Going off on a tangent here. Okay, so on to number two. Make a table that illustrates the velocity v that Jeffrey is traveling after t seconds. Right. So if we say, and I should probably create another slide here that has a table. Here, I'm just going to insert a new slide and make one. So here is time. This is our independent variable, right? And our dependent variable is going to be the velocity. Okay, so time is in seconds, velocity is in feet per second, right? So we go back to what we read. We see the acceleration rate is 64 feet per second per second. So what that means is 64 times the number of seconds, right? That's going to give us our velocity. Okay. So our velocity can be explained that simple. Okay. So at 0 seconds, velocity, of course, is 0. At 1 second, we're at 64. At 2 seconds, we're at 128. At 3 seconds, 3 times 64, sorry, I had to grab a calculator. That would be 192, and so on and so on and so on. Right? So our velocity is a function of time, and it's therefore equal to 64 feet per second times the number of seconds that has gone by. Okay? So that said, that would be our function. If we sketch the graph, okay, it's going to look something like this. We would start at 0. Here is t time in seconds, right? And we'll stop here like at 4 seconds, and 3 seconds, and 2 seconds, and 1. So in 1 second, we're at 64. In 2 seconds, we are at 128. 3 seconds, we are at 192. And you can see where this is going. Okay, we're going to be going stupid fast in a matter of seconds, right? So now, how many seconds will Jeffrey be able to accelerate, or will he have to accelerate in order that he should reach the speed of sound? Okay, so all we really need to calculate is, instead of v of t, right, we need to figure out when his velocity is 1125.33. So instead of v of t, we're going to say 1125.33 equals 64 times the number of unknown seconds it would take, right? And to figure that out, we obviously would divide by 64. Okay, so again, need my calculator here. 1125.33 divided by 64. So when we reach, so if this continues and continues and continues, we're going to say this is 1125.33. Oops, I don't know why I put a 5. Approximately, right? And this is what we're shooting for, right? This is Mach 1. Mach 1 is going to happen in about 17.58 seconds. So way out here at about 17.58 seconds is what it would take. Okay, so if I rearrange my graph to kind of fit what we see here, so of course at 0, let's rescale here. It just bothers me that it doesn't look right. It's probably not that big a deal, but to me it is. So at 0, we're at 0. Okay, then of course we're way up here. Okay, so if I drew this to scale, so that's about 17. Let's say, so halfway, that's about 9 seconds. We'll say 9 seconds is right there. And then this is about 4 seconds. This would be about, we'll say that's 13 seconds. So in 4 seconds, 4 times 64, that would be 256. So in 4 seconds, he's already going 256 feet per second. Okay. In 9 seconds, so 64 times 9 now, he's going 576 feet per second. And then, of course, in 17 and a half seconds, he's reached the speed of sound. Pretty crazy. Okay. So, in a nutshell, that's how linear functions work. You've got a rate of change, you've got a y-intercept, not really anything new to us. Aside from the notation, instead of saying y equals, right, we're going to be grown up and say that y is not really a thing anymore. It's simply the function of x equals and then your function of x. Okay, that's it for this video. Let me know if you have any questions. Otherwise, goodbye.